Good evening, students. Myself is Bandopadhyay, and today I'm going to teach you one more power system numerical. This time we shall focus on power system stability numerical. In the numerical, it's given as that there is a two-pole 50 Hz turbo generator that has a rating of 60 megawatt, that is active power, and its power factor is 0.85 lagging. Its rotor has a moment of inertia of 8800 kg meter square. Calculate its inertia constant in megajoules per MVA and its momentum. Momentum means angular momentum, and they want it in megajoules second per electrical degree. So at first, use the relation for power factor. Power factor is cos phi is equals to, we know, megawatt by MVA. Cos phi is given here, it is 0.85 megawatt, that is active power of the turbo generator is given as your 60. So we can get MVA. MVA means machine rating. In power system stability, machine rating is denoted by G. So G is equals to 60 by 0.85 is equals to 70.588 MVA. Now we can calculate our inertia constant H. Inertia constant H is defined to be as the ratio between kinetic energy in megajoules to that of the machine rating G in MVA. This also we have studied previously in our Google Classroom in power system stability, how we got this equation and how we can utilize this equation. Anyways, so now calculate your kinetic energy, which is equals to normally your half into I into omega square. What is I? I is your moment of inertia and omega is your angular velocity. So moment of inertia is given in the numerical. It is 8800 kg meter square. So half into 8800 into omega, we know it is equals to twice pi f. F is the frequency, that is 50. So hence we get as 434.265 into 10 to the power 6 joules converted into megajoules. That means divide by 10 to the power 6. So we get 434.26 megajoules. Okay, this is the kinetic energy. And in the previous Google Classroom also I have taught you that the product between G and H, is nothing but equals to your kinetic energy. Anyways, so we get our H, inertia constant H, that is 434.26, which is the kinetic energy in megajoules, divided by G. G is your machine rating in MVA, 70.588. Okay, so we can easily get our H. H comes out to be 6.152 megajoules per MVA. Now we know that this also we had initially discussed in the Google Classroom. Angular momentum, it is defined as the ratio between GH to that of your 180F, and we get it in megajoule second per electrical degree. And if we want the answer in megajoule second per electrical radians, then replace 180 by pi. Now we know that initially that GH, the product between GH is also equal to your kinetic energy, and or directly you can multiply G and H, same result you will get, that is 434.26 megajoules. The product between G and H shall give you this value, which is also GH is also equals to your kinetic energy. So either one you can use, it's up to your discretion. So hence angular momentum M is equals to 434.26 divided by 180 into 50, so is equals to 0.04825 megajoules second per electrical degree. This is the answer for angular momentum M. And before that we got our inertia constant H, that was 6.152 megajoules per MVA. So that's it for today. Thank you.